All right. Now,
I still owe you a new song. I'm working on it. So
been
I'll
working on
get
it
'em.
for like 20 years now.
I know it's all good. I just been real busy working OT.
It
I'll
doesn't
get it.
bother me. Hell. It,
Oh yeah.
you know, we're always, we'll change something here and there every now and then when we get to it. I mean, I
Okay.
spent uh, uh, all night last. That's why I forgot that dang picture. I was trying to figure out how to get the damn rumble on, and I was
Okay.
reading all this documentation. I didn't go to bed till 4 o'clock in the morning, and then I
Wow.
turned around, got up at 9, and then had to run some errand stuff. I was like, man, I'm still tired. You can probably tell my eyes are a little baggy today because I'm sleep.
Yeah. So just keep in mind the myth next week will have the picture from this week. So
Yeah.
we'll be all good. But no, I appreciate you, sir.
All right. Now, where we finished up last week was doing motors. So we're going to go through and do the exercise problems for motors, but we're getting close to getting through. Probably if we don't get to it tonight, next week we'll definitely get through all the overcurrent protection devices. And then we get into residential and commercial. So we're moving along pretty good. I mean, we're getting quite a bit done. So, all right, let's get
Okay.
started. Where were we at when we started this? All right. Now, the first one, now everybody remember this. I'm going to sort of go over this a little bit just to refresh everybody. But I said, anytime you're taking and you're sizing your overcurrent protection devices are conductors, you want to use the amperage values that are in the tables in 430.247 through 250. And we get that permission over in 430.6A1. All right. Now, when I'm doing the overload protection, I'm going to look at 430.6A2 and it's going to tell me to use the nameplate. All right. So I just want to make sure everybody sort of remembers that. And one thing I've started with, like I've done every one of these, is I always reemphasize the rule of thumb one more time. If you're sizing your overcurrent protection device at 125% or less, go up to the next standard size. Once you get over that 125% percentage, then what we're going to do is we're going to drop down to the next standard size. The only places you're not going to have that is where I have to protect the conductor, which is sized at 250% for phase converters, and then also transformers. But we went over that last week and the week before, and I was talking about that. And I said, now, when you're doing those transformers, when you're looking at table 450.3A and B, if you don't have that um, superscript one there that drops you down to the notes that allows you to go up to the next standard size. Okay. If it didn't have that superscript one, we dropped down when we got to
Right.
the percentages above 125%. Okay. So just to get that started. Now, when you look at this illustration, basically we just need to know a couple of values here. All right. We know it's a 50 horsepower motor, it's three phase, 460 volt, design B, and we're going to size a non time delayed fuse. So when I go to look in step one and I'm going to get the amperage, since this is three phase, we're going to look at table 430.250, which was permitted once again for 430.6A1. And you go pick up the 460 volt and you come down, line it up with a 50 horsepower, and it's going to tell you it's good for 65 amps. All right.
Right.
Now, the next thing that you're going to get into, and I said make sure you do this in the last week. I said right there at table 430.248 and 250, write down sizing OCPD, and then put 430.52C1, and then table 430.52C1. Okay, that's where we want
Right.
to go because what it's going to tell you in 430.52C1, the heading's going to say in accordance with table 430.52C1, and it says a protected device that has a rating or setting, listen one more time, not exceeding the value calculated. So that means I can't
Sure.
exceed it. So I have to do what? Drop down to the next standard size. Okay. So when I go over to my table, and I come down and I pick up my non-time delay fuse for a full take motor, it's going to tell you to take it at 300. All right. So I'm going to take the 65 amps at 300%. That's going to give me 195 amps. And then if I look at step 4, and I actually go over and I look at 430.52C1, A and B, it's going to tell you, in A, I'm automatically permitted. I can go up to the next standard size if it didn't start the inrush current, which would be a 200 amp. But if it'll start based on not exceeding the calculated value, I can drop down to the next standard size, which is 175 amp. So we got a minimum size at 175 and a next size at 200. Now, you've probably seen some of these arguments on the groups and stuff, and they say, they try to tell you there's no such thing as a minimum. What the minimum is a starting point. Okay. And if you go over, and I give a good example of this, if you go over in the 2023 and you look at 440.22A, what they did, they added text in there, and it looks just like motors. And what I always tell everybody is when you go look at a nameplate, how many times have you looked on there and you have a hacker breaker rating for that AC unit and it has a minimum and a maximum? That is a terminology that has been used, and we've been doing this forever this way. I mean, even when NFPA published our books, the table still stated the same in 430.52, and it says maximum, but that's the maximum percentage for that table. And and you got people like Jeremy and Ted and all of them, they come in, that ain't right, there's no maximum, there's no minimum. And I'm like, I don't know what y'all arguing about. You going to tell me that the staff at NFPA is all incorrect too? Because they added it. We had 3 editors at NFPA looking at the technical validity of what we published, and it's been that way for, God, we've had in the books that way 30 years. I mean, now all of a sudden it's wrong because they say so. I mean,
Yeah, and when have you ever heard about having 2 maximums?
that's true, and that's another thing I brought up to them. I said, well, if I go down and pick up in the 2023 code and I pick up 430.52 C1, and I go down right below that, and you pick up B, I said, what is B deal with? I said, that's maximum. I said, so you're going to tell? I said, are you telling me I have 2 maximums? And they said, there you go. You're just twisting the code to meet your lies. And I'm like, no, I'm trying to tell you that's what it says. But anyway, besides that, and then we'll do the next one, and it's the exact same thing. We're using the same motor thing. The only difference here is I'm doing a time delay fuse. Okay. And if you go look at the table and you pick up your time delay fuse squirrel cage, it's going to tell you take it at 175%. So you just take 65 amps at 175%. That gives you 113.75. The next size below that's 110. And I'm automatically permitted to go up to the next size if I want to. So I could have 110 starting point, or I could go up to the next size due to inrush current because 110 amp didn't hold it, and go to a 125 amp. Okay.
Right.
Now, when I come over here and I look at an instantaneous trip circuit breaker, well, you're going to look over, and if you look at the table, it's going to tell you this, and we have a design B energy efficient motor here. It's going to tell you take it at 1100%. Okay. Now, you take the 65 amps at 1100%, that's 715 amps. That's your minimum setting to start with.
Right.
Then if you go over and you pick up C3 is going to allow you to go up to 1700%, and you'll pick up C3 2B. Okay. And when you pick that up down there, it talks about your design B energy efficient motors, and it tells you, and shall in no case exceed 1700%. Okay.
Oh, welcome in. Thanks for joining us tonight.
Hey, thanks, brother. So take 65 amps at 1700%. That's going to give you a maximum setting of 1,105 amps. Now, the point behind this is we're using the same type horsepower rated motor and all that. But what we're trying to point out here is it just comes down. You're still following the same type step-by-step method. You just have to find the percentage that's going to apply. So when I look at this next, and it's an inverse time circuit breaker, and if I look at the table for my 50 horsepower, 460 volt three-phase design B, it's going to tell you take it at 250%. So if you notice, based on the table, for non-time delay, we took it at 300%, time delay 175. Then when I got up to my instantaneous, I took it at 1100%. Then I had to look at C3, allowed me to go to 1700%. And then you look here at the table for my inverse time, it tells you take it at 250. So I take 65 amps at 250%. That gives me 162.5 amps. The next size below that's a 150. And then if it won't start due to inrush current, I can just go up to the next standard size and put a 175 amp overcurrent device there. Okay?
Yeah.
Now, when you look at that, that's not hard. And a lot of people have a lot of problems following how to do these motor calculations, transformers and stuff. If you just follow this step-by-step procedure and learn where to get the percentages, you're not going to have a problem putting this together.
And I'm going to put this thumb roll up for everybody. This is one of James's thumb rolls that he does. And I say generally just because there's a couple instances where it doesn't apply with phase converters.
Well, we're going to do that tonight, the phase converter. We've already done the transformer and showed that, and we showed the notes in there for that. Okay?
Okay.
Now, this one, this is your maximum size. Okay? Now, all I'm going to be doing is looking right at 43052C1 and come down, depending on what cycle you're in, you'd be exception 1 and exception 2, or if you're in 2023, it'd be C1A and B. Okay? So it's same calculation, same percentages. They just changed instead of exception, it's full code text now. But look at this. I've got the same motor here. Okay? Now I'm going to look at the maximum, and if I drop down to exception 2, or I'll look at C1B, depending on which one y'all are looking at, you come down, you pick it up, it's going to tell you that if I have non-time delay fuses, I can increase those, and it says shall be permitted to be increased. And listen to what it says, but shall in no case exceed 400%. So it says I can't exceed. That means I got to do what? Drop down. And that's another percentage that's above the 125%. So if I take the 65 amps at 400%, that's going to give me 250 amps, and you'll need a 250 amp overcurrent protection device. Okay? Now, if I come over here and I look at my time delay fuses, and you come down and you pick up your time delay fuses, it tells you it's permitted to be increased, but in no case shall it exceed 225%. So I take 65 amps at 225%, it's 146.25 amps. The next size below that per table 246A, where your standard overcurrent device ratings are, that'll be 125 amp overcurrent device. And then when I get to my inverse time circuit breakers, exactly the same thing. Just like I had for that. Now, the only thing you have to look at here, the 400% is where the full load currents are 100 amps or less. If that horsepower motor was greater than 100 amps, you'd take it at 300%. Okay? But this one, it's less than 100, so you just take the 65 amps times 400%, it's 260 amps. The next size below that is what? A 250 amp. Now, that's not hard to follow. Now, the next one I'm going to get into is going to be where I have multiple motors. When you get into the multiple motors, like we talked about, we used to actually have this in our publication a little bit different. We used to take and do the calculation and drop down to the next standard size, add them up, and then go up to the next standard size. Well, the code making panel come in and they said, no, we want to do it this way. We want to take and calculate it, go up to the next standard size, add them up, and then drop down. Okay? So we changed this up from what they did, and that's probably like 3 cycles ago. I think they did this. Okay. But in this case, we got 4 motors. They're all 3-phase, 460 volt design B. I've got a 15, 20, 25, and 40 horsepower motor. You go over to table 430.250. You pick up your 460 volt, come down, pick up your 15 horsepower. Tells you it's good for 21 amps. The 20 horsepower is good for 27. Your 25 horsepower is good for 34 amps. And your 40 horsepower is good for 52 amps. Then you're going to go look at table 430.52C1. You'll pick up for an inverse time circuit breaker is what we're sizing here. And you come across, it'll tell you take it at 250%. And then you take that 250%, that gives you 130 amps, and go up to the next standard size, which is a 150 amp overcurrent device. Add the other 3 motors together, gives you 232 amps. Then you drop down, which would be a 225 amp overcurrent device. Okay? Right. So hopefully everybody that's been doing their homework got all these right. All right? And then when I get in and I start doing my overload protection, one of the things I told you is go look at 430.6A2, and it tells you when you're doing your overload protection to use the nameplate value. Now there's 3 items I need to look at here. I don't even really care what size motor is or what voltage it is. I want to know the nameplate, I want to know the temperature rise, and I want to know the service factor. That's it.
Right.
Now, we talked about this last week, and when you go over and you look at 430.2A, it tells you, well, you have a motor with a service factor 1.5 or greater. So I got 1.15 or greater, and it says a temperature rise that's 40 degrees C or less. Okay? You'll take those at 125%. If you don't meet both of those, then you have to take it at 115%. Okay?
Okay.
So my nameplate value is 62. I met the temperature rise and service factor, take it at 125%, and that's going to tell me that my overload devices there will be rated at 77.5 amps. Now, if I need to go to a maximum size, then you're going to look over and you're going to pick up 430.32C, and when you go pick that up, you get the exact same language. The only difference is it tells you it's 140% if you meet both of them. If you don't meet both of them, then you got to take it at 130%. Well, in this case, we just kept it the same motor, so we know we met it. So you'll just take the 62 amps at 140%, and that'll give you 86.8 amps for the overload device. All right? So up to this point, that's pretty simple. Okay. Now, the next thing we're going to do to get you ready for next week in the homework, the first one we're going to do here is we're going to be looking at sizing the overcurrent protection device where I have a phase converter. So in this case, I've got a 20 horsepower, 3-phase, 230 volt design B motor. Now, like I said, when you're sizing the overcurrent device, 430.6A1 will tell you to go look at the tables. In this case, since it's a 3-phase, we're looking at table 430.250. And if I pick up my 230 volts and I come down, pick up 20 horsepower, it's going to tell you it's good for 54 amps. Now, what you're going to get into, you're going to go over and you're going to look at 455.7B because we're dealing with phase conversion here. And when you go pick up 455.7B, this is where we're going to be. Now, if I was doing a variable load, would be different. And then I've got one that I'm doing a fixed load. This is a fixed load here. Okay. And when you're sizing your overcurrent protection devices here, you have to look at this, and it's going to tell you to take that at 250%, and that'll give you 135 amps, but it's going to tell you you have to protect the conductor. So the next size overcurrent protection device above that for table 240.6A is 155 amp. Now, one of the things I like to do when I'm going through this kind of stuff like this is I like for everybody to go through and see just exactly what it says. Because when you look at 455.7b, it's going to tell you the overcurrent protection device determined for this section shall not exceed 125%. But if you look at that and it talks about above that, or the first sentence, it talks about the fixed loads and conductors are sized in accordance with 455.6A2. And then when you go up and look at that, that's when it tells you an ampacity not less than 250%. So some may miss that. You have to pay real close attention, because when you're doing a test, they ask you to size fixed load for a phase converter, and you go down and look at overcurrent protection. If it's got a section in there like this one does, you need to know you got to go back to 455.682, and that's where I picked up that 250%. Okay.
So I got a quick question for you on that step 3 where it says table 240.4G. Is that a table, or
Yeah.
is that just?
Yeah.
Are you talking about the list of?
Yeah,
about the list of items.
Yeah, that's where you pick up specific conductor applications, and that's when I talked about you get into these different percentages that could be higher, and that's where it tells you. Yeah, I put that in there just so as a reminder. Where did I get the permission to get me over here to do that? And I started that in motors. Matter of fact, in motors, when I first started, I went through table 240.4G. And
a lot of people will get hung up like on an exam because a lot of people don't read past 240.4D. So like you'll sit there and think, well, if I got to 240.4D, I can't even do any of this stuff. I don't even have permission to do any of this. But that's why you have to just read down and make sure you read down to 240.4G to make sure that whatever you're calculating is that specific conductor.
Correct. And that's why we go through these, and explain it step by step. And when you look at it, it's really not hard when you see the step procedures we put it in. Like this in here, this is simple. I just know what I'm looking at here. I know I've got to get the amperage, and I'm sizing an overcurrent device, so I know I have to use one of the tables. If I was doing overload, I know I need the nameplate. So I'll just get the amperage here. And based off what you just learned, we got a fixed load here. It's a specific load. So I'm going to put 250% on here. And you just sort of learn the sections. And that's why we go through this over and over and over. It's almost like repetition, but it's different items. But I'm really never changing anything. It's just what I need for this, what I need for this. And I'm still applying the same type of calculations. And I'll tell you one of the things that's very interesting about this. If you ever notice, pretty much everything I start off with is getting what? The amperage.
Yeah.
Even when I size my transformer, get the amperage. Once I get the amperage, then I'm looking for what? Percentage.
Yeah.
That's pretty much the way you do everything. Okay.
Right.
Now here's an AC unit. Okay. So I've got a compressor load of 21 amps and a condenser of 1.5. Same principles apply here. When I look at this, I'm going to look over at 440.228. Now, some of y'all that have your 2023, because we're doing this on 2020, but I do like to take and tie in the 2023 if there's a change that's made. And when you go over and look at 440.22A, they sort of did it like they had it in the last cycle. I expect this eventually to be 440.22A, A, and B, okay, and C. But right now they have them as exceptions like it used to be in 430.52C1. Now, when you look at this, when you pick up 440.22A, it tells you that you're going to be doing a protective device having a rating or setting. Now, listen to what it says again. Not exceeding 175%. It says I can't exceed, so that means I'm going to do what? Drop down. Now, what they added in the 2023, they added an exception 1 here, and they said without doing any other type of calculation or anything, I'm automatically permitted to go up to the next standard size, And if it still won't start due to interrupted current that motor, then you got an exception too, and it tells me I can take it up to 225%. Well, that's interesting because this looks just like the motor portion now, but yet I used to come in and I'd look at a AC unit and I'd have a hacker breaker rating there that had a minimum and maximum setting.
Right.
Well, where did they get that minimum maximum setting from? There had to be a percentage they had to go by. Well, they went by the code because it's designed that way. Okay. Sure. And that's one of the things when UL is going out and they're listing and labeling equipment, they're going to look at the equipment and they're going to take the NEC into consideration. So if you have a UL listing and like say they have it for EVSE and they tell you don't put GFCI on it, guess what? The NEC was taken into consideration. And for somebody to come in and say, oh, no, you can't do that. You have to take and put GFCI on it. The code overrides it. No, it doesn't. It doesn't override the manufacturer's instructions because all that was taken into consideration when they gave the listing and labeling. So the same thing happens here. I've got a minimum and maximum size rating that was on that HVAC equipment. And what was that based on? It was based on the percentages in the code. All right. Now,
yeah, and this brings up an interesting point too. Like if you look at that, you have like let's just say you have a 21 amp full load current, and you say, you know what, I'll use a number 12. You should be covered, and then you put it on a 40 amp breaker. It's code compliant from the minimum, but if worst comes to worst, you know that AC unit might give you permission to use like a number 10 with or number. I've even seen them do a number 12 to a 50 or a number 10 to a 50 or whatever. Mm-hmm. And if you drop to too low of an overcurrent device, then that overcurrent device is going to nuisance trip.
That's right. Sure. Well, so then you know you need to go up. That's why they give you these different options. Right. Now, the other thing I'll say here is this is just like motors. When I do a motor, you take the largest motor at 125%. All other motors are added at what? 100% for sizing the conductors. The same thing applies here when I'm doing the overcurrent device. You take the largest at 175% for this case for the AC unit, and then you add the condenser on at 1.5 amps. Okay, so I take 21 amps at 175% and add that 1.5 onto it. That gives me 38.25 amps. Now I just read to you, it says it can't exceed the calculated value. So I look at table 240.6a, the next size below that is a 35 amp. Okay. Now I will tell you in the 2023 cycle, I've already added another step here. I've added step 3 that will pick up 440.22 A exception 1, and you'll be able to put a 40 amp there. Then I go down to the maximum size, which will be exception 2, that says I can take it at 225%, but I won't exceed the calculated value again. So I take the 21 amps at 225%, add that 1.5 amp condenser on there. That gives me 48.75 amps. The next size below that's 45 amps. So this calculation is actually changed in the 2023. I would have a 35, 40, and 45 amps set there. Okay?
Right.
Because you need to be aware of that.
One thing I want to mention too is when you're sizing on these AC units, all you have to cover is the minimum circuit ampacity. So if it says like a minimum circuit ampacity of 21 amps, you think, oh man, I can't put a number 12 on there. That's not true because the AC unit has 75 degrees C terminals. So all you have to do is go to that 75 degrees C column, and then you just go to that value, which number 12 is good on THHN for 25 amps, and then you can use a number 12 over 20 amps as long as you're in that 240.4G column with the AC unit.
Sure. And one other thing I want to point out is some will say, why didn't you go over and use the tables in 430.247 through 250? The reason is because this is an assembly. All right. So it's one unit, and therefore you're going to use the nameplate value that's on there. Okay. And this in here, you got a condenser of 19 amps and 1.5. You should automatically learn this. I'm going to go to 440.22A. I'm going to take it 175 amps. If I need to do a maximum, it's 225%. Okay?
Right.
And then if they just say next size and they're doing the 2023 code, then you would do the minimum and just go up to the next size overcurrent device. Okay?
Right.
Now, this is where we get into welders. All right? Now, you're going to go over and you're going to look at 630.11A. Now, when I get over here and I start looking at this particular chapter, there's 3 types that you're going to look at here. And you're going to have your resistant type welders, and then you're also going to have your non-motor generator welders and generator type welders. All right. Now, when you go over and you look at 630.11A, it's going to tie you in with table 630.11A, and that's where you're going to get your duty cycle multiplication factors for the arc welder. All right. So this, once again, and think about what I'm saying here, it's just like the AC unit. That is what? An assembly. It comes as one unit. So you're going to use the nameplate value here. Okay. So in this case, I've got a non-motor generator arc welder. It's 54 amps and it has an 80% duty cycle. Okay. So the first portion in step 1, get your amperage. That's what we always do. So we know it's 54 amps. Now I'm finding a percentage again. So I'm going to come over and I'm going to look for a non-motor generator type. I'm going to come down and I'm going to look at 89% come across. It's going to tell me that the duty cycle is 80%. So all I'm going to do is, I got a little mistake there. Oh no, that is my multiplier, 89. So I take that 80% duty cycle with a 0.89 multiplier, and it's going to tell you that it's good for 48.06 amps. Now I'm going to look and I'm going to do this, and I'm going to look at the conductors also here, because I'm doing the conductors and then I'm going to do the overcurrent device. And if you look at the overcurrent device, and just to get people in the right direction to start off, I pick up 630.12A. It tells you should have an overcurrent device rated or set, and listen to what it says one more time, at not more than 200%. So that, once again, you can't exceed it because it says not more. So here's another high percentage where we're doing what? Dropping down to the next standard size. So this in here, I'm going to size the conductor, which is a number 8 conductor. I go over, look at table 310.16, and I pick that up for 75 degrees C column. The next size above at 48.06 amps is 50 amps, which is number 8 conductor. Now I'm going to look at sizing the overcurrent protection device. So I'm still going to use the nameplate of 54 amps. And then I'm going to look at 630.12A, and you look at 12B, it all ties in the same there. It's going to tell you take it at 200%. So I take 54 amps at 200%, gives me 108 amps. And I can look at this 2 ways to what I can take and provide this protection. Now, I can say, all right, I'm going to protect the conductor 110 amps, but I'm going to see if I could just do 100 amps. Okay, which I can already tell you it is, because if I take 50 amps at 200%, what does it give me? 100 amps. See that? So I cross-check myself, and I could have just dropped down because I did go at the 200%, but I just went up to 110 amps just to sort of show you. A lot of people will say, I'm going to go up to 110, but really, would I be able to go down to 100 amp like it's saying not to exceed it? Well, sure, because I just put 50 amps on at 200%, gave me 100 amps. Right. So that is a good way of learning here. And you're learning the proper procedures to do these calculations. And then here, I've got 68 amp, and I've got 50% duty cycle. Okay, same calculation you're going to apply here that we just did. and you're going to do the conductors, and then you're going to do the overcurrent devices and see which one's the largest. I can already
Dude,
tell you. Listen,
were you running around in my garage taking a picture of my welder or what?
I'm gonna tell you what.
Just like my.
That there are some very good illustrations that have been done.
That's a spitting image of my welder I got in the garage.
Yeah, the illustrations are fantastic. What's coming out, and I'll tell you the grounding and bonding, man, it looks freaking fabulous. But the one I'm looking the most forward to, because they're going to redraw all new equipment and stuff, just like as close as we can draw it to where it looks like it, is going to be in the hazardous location area, because you got all them bolts on it, and everything that they've already have drawn the purge and pressurized X, Y, and Z. They've got a couple of pieces already drawn of the explosion-proof equipment. They drew new seals. I mean, it's looking pretty freaking kick-ass.
Well, if I find them roaming around in my garage, man, I'm gonna want my cut, man.
All right. Now, this one is where the one we did before was non-motor. This is a motor generator type. All right. Now we're just going to show you doing it without doing the conductor first, because I can tell you can do the conductor, but before you said something, I was saying I can already tell you which is going to be the largest. It's going to be taking the 200%. But the reason we did that one before is to show you we took the conductor and got the amperage, took it at 200%, and it matched up to exactly when we dropped down. You see, and that proves everything that we're teaching you. Okay.
Right.
So this, and I've got a 68 amp load, and it has a 70% duty cycle. Now, look, if I was sizing the conductor, I definitely would do that 70% to size my conductor. But what we're trying to point out here is really all you need to do, you're sizing the overcurrent device, so I'm going to take it at 200%. Right? So if I take 68 amps at 200%, it says rated or set not more than 200%. That means I can't exceed it. Okay?
Right.
So the next size below that 136 amps is a 125 amp overcurrent device. Okay? And then when you come over here, you pick up a motor generator arc welder. So we got you an easy calculation. You know the welder. Looking at this, it's 76 amps. And we're just going to get the percentage. So I'm going to look at 630.12 A and B there. You're going to know to take it at 200%. Don't exceed the calculated value, and drop down to the next standard size for your homework next week. Now, this one, we're going to prove this to you one more time. We're going to show you a resistance welder here. Now, in this one, you're going to look at 630.31A. Now, when I'm doing non-motor and generator type, I'm in 630.11A. Resistance, you're going to look at 630.31A. Now, this, and I've got an 84 amp primary, and I got a 50% duty cycle. Okay? So I automatically know my amperage, 630.31A. I'm going to use the nameplate, which is 84 amps. Now, I'm going to look at this table down here, and I'm going to pick up 50% duty cycle. It's going to come across. It's the first one in the table. It's going to tell you as a multiplier of 0.71. So I'll take the 64 amps at 0.71, gives me 59.64 amps. I look at table 310.16, 75 degree C column. The next size above that, 65 amps, which is a number 6 conductor. All right? Then I'm going to do my overcurrent device. Now, the only difference between these two, when I look at 630.32A and you're doing a resistance welder, you're going to take it at 300% instead of 200%. Okay? So I'm going to take the 84 amps at 300%, and that's going to give me 252 amps. Now, we're going to show you, looking at this overcurrent protection device, I'm going to do it one more time. I'm going to go up to the next standard size just to show you here. So here's 300 amps. Now, if I look at protecting the conductors, if I took that 65 amps at 300%, that gives me 195 amps. The next standard size above that is what? 200 amps. 200. So instead of putting a 300, I could drop down to the next standard size below that 252 amps. I could have went to a 250 Or I could protect the conductors based on the 300%, which is what? A 200 amp. See the difference there?
Oh yeah,
Most
we got
people would
number.
go to a 250, but you actually could go to a 200 here.
Yeah. So now the legend of the number 6 on a 200 exists.
Yeah. But look at that. That's interesting because a lot of people would just assume do the 300% and say, oh, I'm going to put it at 250 amps. Or some may screw up and go to 300 amps. I'm saying I'm going to cross check this to see if I'm
Right.
right. So I'm taking that 65 amps at 300% for when I size the conductor. I come up with 195 amps. I just went up to the next standard size, which is a 200 amp. And that works
There you go.
perfectly fine. And I
Yeah,
guarantee you,
and
go look at some of these other publications out there. You won't see this. And
yeah,
we do certain problems in here a certain way because we want you to think about what you're doing when you're taking these tests. And these are
mhm,
type of questions they'll trick you on. You may look at that
yeah,
and say, "Oh, it's 250." Well, if you'd have looked at the conductor took it 300%, you'd realize actually they're telling you the minimum that they put on there is a 200 amp.
right. And we really appreciate everyone smashing the like button. We got a bunch of likes in there tonight. Really appreciate it.
Oh
Thanks
yeah,
so
thank you
much.
guys. Appreciate that a lot. Now look at here. That's a good looking resistance welder they did there. I tell you,
Yeah,
they put a lot of detail in these illustrations. And I'll tell you, when you throw it up on a big screen, they even look even better. I mean,
right.
because you see the detail that's in them. I mean, they put, I mean, they blow them up and put the text in there just like you would see on a regular unit. So, I mean, they really do their work good. And then
Right.
this one here, I've got 91 amp resistance welder with a 40% duty cycle. So you know you're going to look and get your amperage first, and then you're going to get your duty cycle and then work down based on the conductors in that 300%. Okay. And that way you'll know if you sized it correctly or not.
Right.
All right. And the next one we're going to look at is looking at control circuit conductors. Now, this particular one is where the conductors are located in the controller. And remember what I said when we were doing this. This is a verification for when you go look at 430.72B2. And I said when you're in there, it's going to have below the table, you're going to have your notes there and everything where all this ties in together. Okay.
Right.
And basically, when I look at this, since you're inside the enclosure, I said you're going to be looking at table 310.17 because that's considered to be in free airspace. Okay.
Right.
So if I go over and now the other thing I'm going to point out, it's also going to tell you that you're going to use a 60-degree C column in this one. Okay. When I get to where it goes through the conduit over, then it's going to tell you use the 75-degree C column. So if I go look at table 310.17, pick up a number 12 conductor, it's going to tell you take it at 30 amps. And all I'm doing is checking here is the percentage that I'm going to be allowed here for the size overcurrent device that's required for the number 12s on those control circuit conductors. So it's going to tell you take it at 400% in table 430.72B. That's going to give you 120 amps. And I said anything over 125%, what do? Drop down. So the next size below that's 110 amps, and you'll see that all matches up with sizing the overcurrent protection devices. All right.
Right.
And then here's showing you an illustration where I have the controller there and you got the control conductors inside that enclosure. Okay. And just remember, you got this, and we're doing a number 14 conductor. Just remember, because you're inside the controller, that's free air space. We're going to use table 310.17, and then I'm going to use a 60-degree C column and then take it at 400%. And you'll be able to size it. And remember to drop down to the next standard size. Now,
Right.
this is one where I'm running remote from the controller. Same exact conductors and everything, but looky here, now I'm using table 310.16. It's good for 20 amps, and it's going to tell you to take it at 300%, which equals up to a 60 amp overcurrent protection device.
Right.
Okay. And all of this is, this is just a verification. The information's already in the table. All we're doing is showing you below the table and the percentages. How did they make that determination? This is how they did it. Okay.
Okay.
And then you'll see here we have the control circuit conductors run remotely over here. And then you need to use table 310.16, 75 degrees C column, take it at 300%, and then size your overcurrent protection device accordingly. All right.
All right.
Now, this is where you're going to get over and you're going to look at 430.72B exception 2. All right. Now, this particular one, when you look at this exception, this is where you're on the secondary side of a single phase transformer. And what it's going to tell you here is where you're going to be able to take this at 167%. So what they're going to tell you is in 430.72B exception 2, it's going to tell you to come in, basically, I need to determine my amperage. So this is very simple. You just get the VA of transformer, divide it by the voltage, there's your amperage. So we always get the amperage first. And then you're going to go back and you're going to look at table 450.3B. Okay?
Right.
Now, this is very simple because when you go over there and you look at that, I'm just doing the primary only here because we're talking about required for a primary 2-wire transformer here. And you go over and you look at currents less than 9 amperes. You come in and then you look at the next column. It says currents less than 2 amperes. So I'm between 2 and 9 amperes, right? So if I come down and I'm doing primary only, it tells me take it at 167%. But when you look at that table, you're going to notice there's no superscript 1 there like we talked about the other day. So if there's no superscript, what do? I drop down again.
Yep.
Okay. So you take the 5 amps at 167%, that's going to give me 8.35 amps. So the next size below that, standard size per table 240.6A, is a 6 amp overcurrent protection device. Okay.
Right.
And then you got the same thing here. You got a control conductors, or your control conductors, you got a control transformer there. Well, what do I have? I have a 2200 VA transformer. It's 480 volts. You're going to divide in that, get your amperage, then you're going to go look at table 450.3B to get the percentage. So in this case, if I was below 2 amps, then I'd take it at 300%. See that? And that's where you're going to look at table 450.3B. But I'll point out again, you're going to notice there's no superscript 1. Now, if I'm over 9 amps, then you take it at 125%, and guess what's there? A superscript 1, which means I go up to the next standard size. Okay?
Hey, I have a quick question for you. So is there any text at the top that's getting blocked off by like our live and by like our thing? Is there a way we could maybe shift that down a little bit so that, like, I'm just saying in future, like, I don't know if there's anything
What's
getting
being
blocked.
blocked?
So, like, I don't know for sure if there's additional text in there because it says overcurrent protection, but I know sometimes you have like text up there. I just didn't know if there was a way you could drop that text down. I was just questioning.
I can't drop that any. That's full screen right there.
Okay, gotcha. I was just curious because I just didn't want anybody to be getting any words blocked by that at the top.
Yeah, the only thing that's up top is just telling you what we're doing. It's just telling you what it is. Like it says overcurrent protection device, and we're doing remote control signaling and power limited circuits. And then at the very bottom is some sections that address that you might want to look at.
I just wanted to do like kind of a frequently asked question thing that people ask.
Okay.
No worries.
All right. Then we're going to do another one here. And this is where we're going to size the overcurrent protection device. And what size is required, where I have number 12 control circuit conductors that are tapped from the secondary side of a control transformer. And the primary is 480 volt and the secondary is 240 volt. Okay. So what I need to do, and you'll remember this, where we're tapping, I said always when you're tapping, you got to get what? The ratio of the transformer. So I would take the 480 volts divided into 240 volts. We're telling you here that the number 12 has an ampacity of 25 amps. So take that ratio of the transformer times 25 amps. That's going to give you 12.5 amps. And then I'll drop down to the next standard size overcurrent device.
Right.
Okay. It's all very simple, but what is the main thing I did? I got my amperage first. That's all I'm trying to do. And in this case, there's no percentage or anything. All I'm trying to do is determine this based on the ratio of the transformer. Okay. And basically the ratio of the transformer, when you see that and you do the calculation, you're going to see it matches up to the conductors. That's basically what they're doing here. Okay. So we just try to prove everything basically, so you understand what you're looking at. This in here, you got number 10 conductors, okay, with a 408 volt primary and 200 volt secondary. So divide the 480 into the 240 volt and get the amperage number 10. That'll give you the amperage, and then drop down to your next standard size. All right. And then we're getting close to finishing this up. This is awesome. Now we're going to look a fire signaling circuit. This is actually given to you when you go over and look at 760.43, but we're just sort of proving a couple of things here. When you look at table 310.16, you pick up 75 degrees C columns, tell you number 16 is good for what? Number 10. Therefore, you look at 760.43, it matches up. You need a 10 amp overcurrent protection device. Pretty simple. And then we did a setup here. This is actually a pretty cool illustration because they actually come in and drew the new equipment and everything, and what you would see, the activated extinguishers, the alarm, the detectors and everything like you would see out in the field. And we're going to have you do here a number 18, number 16. You're going to do the exact same thing. You're going to go look at table 310.16 and size the amperage there, or get the amperage, not size it, and then size your overcurrent protection device for those signaling circuits. All right. And then this one here is where I'm going to get in to medium voltage here. Okay. And we look at this, we're going to do 3 1/0 aluminum conductors, and they're in an isolated conduit that's installed in air with a 3-phase supply voltage of 12,470 volts. Now, when you get into this, you got to look at your different conductors, because you're going to pick up table. Now, it used to be 310.60, but now they created a new article there, and you've got article 311, and you would be looking at tables 311.60, and if I'm not mistaken, I think it's like 52 to 72 or something like that. I can't remember them all. And then you go over there and you pick up your amperage for a 1/0 aluminum, and it's going to tell you it's good for 150 amps. And then when you go over and look at your long time trick element circuit breaker rating in 240.101, it's going to tell you to take it at 600%, which will give you a circuit breaker setting of 900 amps. Okay, next one we'll do is a fuse, and I think we're done with this, if I'm not mistaken.
What happens if they have to turn it up to 901?
Yeah. No, I'm just kidding. Got it out, Paul. You don't know what you're talking about. Now, this one has 3 3/0 aluminum conductors. Once again, it's type NV90. You're just going to go over, look at the table. You'll look at, this case, table 311.60 C74, get your amperage, and then come put your percentage on it, and then size your overcurrent device accordingly. All right. And then here's your fuse rating. It's the exact same question. The only difference is, and if I have a circuit breaker rating, it tells me to take it at 600%. But for a fuse rating, it tells me to take it at 300%. And it'll tell you here that you take the 150 amps at 300%, and you'll have a fuse rating of 450 amps. Okay. Nice. And you'll notice here, I got the exact same problem I had before. You're just going to take and do it at 300% instead of 600% to get that fuse rating size. All right. And that does complete us